Hello everyone. My name is Ashwin Saxena and welcome to our CHE 201 term project group 3. Our topic is Newtonian and non-Newtonian fluids. Our group members are as you can see on the screen. Let's start. First of all, giving an intro about fluids. So a fluid is a substance that flows and deforms continuously upon applied shear stress, which is force. It includes both liquids and gases, which of course take the shape of their container. Fluid behavior is governed by properties like viscosity, pressure, density, and the study of fluids or fluid mechanics is essential for understanding of flow in engineering, biology, and of course in industrial systems. So our project compares Newtonian and non-Newtonian fluids based on how their viscosity changes with applied stress. Moving on, first of all, talking about Newtonian fluids. So a Newtonian fluid is a fluid whose viscosity remains constant regardless of the shear rate, which is applied force. It is a type of fluid that flows in a very predictable way, no matter how fast or slow you stir it, or how much force you apply on it, its viscosity remains the same. So when we apply more force, the fluid's flow increases proportionally. Because of this, the relationship between shear stress and shear rate forms a straight line graph. Some common examples of Newtonian fluids include water, air, alcohol, glycerin, etc., etc. Moving on. Talking about the Newton's law of viscosity. So Newtonian fluids are the fluids which follow the Newton's law of viscosity, which states that shear stress applied to a fluid is directly proportional to the rate of shear strain. Tau is equal to mu du by dy, where tau is the shear stress, mu is the viscosity, du by dy is the velocity gradient. You can see the diagrams describing this. Moving ahead. Uh, Now, doing a distinction between low viscosity and high viscosity fluids. So low viscosity fluids are the ones which flow quickly, feel thin, and the molecules have very less resistance between them. On the other hand, high viscosity fluids flow very slowly and have a lot higher internal resistance between their molecules. Examples of low viscosity fluids are water, alcohol. Examples of high viscosity fluids are glycerin, vegetable oil, and this table here describes some of the common examples of Newtonian fluid and their viscosity values. Now talking about the Reynolds number, which is a very important concept in itself. So Reynolds number compares the inertial forces to the viscous forces. Its formula being rho Vd by viscosity mu. Uh, and it is also used to determine whether a flow is laminar or turbulent. So now we need to define what is a laminar and turbulent flow. So laminar flow, first of all, is when the fluid moves in smooth, right, parallel layers with each layer sliding gently over one another. Turbulent flow, on the other hand, is when the fluid moves in a random, swirling, chaotic motion. The layers mix continuously, creating eddies and fluctuations in velocities. Laminar flow is when Reynolds number is less than 2100. Turbulent flow occurs when Reynolds number is greater than 4000. You can see the diagrams which describes the laminar and turbulent flow evidently. Talking about some real life applications of Newtonian fluids. First of all, in water supply systems. So water is a Newtonian fluid, of course. So engineers can accurately calculate flow rates and make our lives easier by everyday water distribution. Next application being lubrication in machinery. Newtonian oils provide smooth and consistent lubrication in engines and machines. Third use case being inkjet printing. Ink in printers flow with a constant viscosity, allowing tiny ink droplets to be placed precisely to produce clear text images. Moving on. Yeah. Now talking about non-Newtonian fluids. So it's actually when the liquid don't play by the rules. As you can see in the animation that a man punches the fluid, but it becomes a solid instead when the punch lands. So defining it, a non-Newtonian fluid is a fluid whose viscosity changes when a shear stress is applied. It does not follow Newton's law of viscosity. Instead of having a constant viscosity like water, these fluids either become more liquid or more solid depending upon the force applied on them. Example, you see when we shake a ketchup, it becomes thinner. Moving on to the types of non-Newtonian fluids. First of all, shear thinning. It's also called pseudoplastics. These fluids become less viscous when force is applied. Examples being ketchup, blood. Next being shear thickening, which is also called dilatant. These fluids become more viscous when force is applied. The major example being honey. Next, Bingham plastic. These fluids behave like a solid until a certain amount of stress is applied. After that point, they behave like a liquid. A major example of this is toothpaste. Next is thixotropic fluids. So these fluids become less viscous over time when continuously sheared. Thixotropic ink is a key feature of the Fisher spaceman used for writing during zero gravity space flights. Rheopectic, these fluids become more viscous over time with constant shearing, example being printer inks. Talking about some real life applications of non-Newtonian fluids. First of all, industrial uses, the use of paints and inks, which is example of the shear thinning, non-Newtonian types. Uh, Next being shock absorbing materials like in sports gear or body armor, which is example of shear thickening. Uh, Talking about medical field uses, you can see that in blood flow modeling, the blood is a shear thinning fluid. Drug delivery gels that adapt to pressure or temperature, they are also non-Newtonian. Next, consumer products like toothpaste, shampoo, as we already discussed, are all non-Newtonian and are widely used in real life. Concluding our project, so fluids, of course, behave differently on how their viscosity responds to applied force. Newtonian fluids have constant viscosity, so their flow is simple, stable, and predictable. Examples include water, air, alcohol, glycerin, dot, dot, dot. Their behaviors follow Newton's law of viscosity and easy to analyze. The flow is very easy to analyze. On the other hand, non-Newtonian fluids have viscosity that changes when force is applied. They can become thicker, thinner, or even behave like solids under stress. Examples include ketchup, paint, blood. The flow behavior is very difficult to analyze and is often influenced by the fluid's internal structure and interactions. Okay, so yeah, that was it for our project. Thank you very much for listening. Thank you.